The triangle inequality theorem says that any two sides of a triangle has to be greater than the third side. So if we look at example 1, is example 1 a triangle? Well, if we look, it has three sides, so it should be a triangle. But if we examine the triangle a little bit further and use the triangle inequality theorem, we can make our final decision. If we look at side 2 and side 8, 2 and 8 are bigger than 4. And 4 and 8 together is bigger than 2. But if we look at 2 and 4 together, the sum of 2 and 4 is 6. And 6 is not greater than 8. If I drew this triangle to scale, I would have a side that is 8 long, a side that is 2 long, and a side that is 4 long. This side that is 2 and this side that is 4 would not be long enough to meet in the middle. They would be too short. This would actually not be a triangle. This triangle is not drawn to scale. If we look at example 2, again, 4 and 10 are greater than 6. And 6 and 10 are greater than 4. But if we look at 4 and 6, the sum of 4 and 6 is 10. So if we tried to draw this triangle to scale, we'd have a line that is 10 long, a line segment that is 4 long, and a line segment that is 6 long. And if we tried to connect those pieces together, we'd end up with one coincidental line. So this one is also not a triangle. The only way we can get a triangle is when our two sides together are long enough, bigger than that third side. If we look at example 3, what are the possible lengths for the third side? Well, let's call that third side x. Could x be 1? Well, if x is 1, these two sides together would be 14, and they wouldn't be long enough to meet this 18 side. So x for sure has to be bigger than 1. But could x be like 50? If x is 50, then these two sides together are too long for this side. So there has to be a range for x. X can't be bigger than a certain number, and it must be bigger than another number. To figure out the values for x, we need to set up three inequalities. The triangle inequality theorem says any two sides of the triangle added together have to be greater than the third. So I'm going to start with 13 and x. And then I'm going to set up another inequality and say x and 18 has to be greater than 13. And my third possibility, 13 and 18, have to be greater than x. Now in each one of these inequalities, I'm going to solve for x. Thirteen plus 18 is 31. And I want my x value to be on the left side, so I'm going to flip this inequality around and put the x on the left and the 31 on the right. And this says 31 has to be greater than x, which means when I flip it around, x has to be less than 31. Now one of these inequalities I can throw out. X greater than negative 5. Well, if we look, we're never going to have an x value that's negative. So I can throw out this inequality. Algebraically, I need to find it. Geometrically, it doesn't make sense for this problem. So my two answers are x has to be greater than 5 and x has to be less than 31. That creates my range for my x value. I can combine these two inequalities and write it as one and compound inequality. 5 is my smallest number. 31 is my greatest number. X has to be between 5 and 31. So I'm going to use a less than symbol here, which means X has to be less than 31. And I'm going to also use a less than right here, which means that 5 has to be less than X. Or in other words, X has to be greater than 5. This inequality works. X can be any number between 5 and 31. So if X is 7, 7 is a possible length for a side of this triangle. If X is 5, 5 would give me 18 together, and no, it wouldn't be a triangle. So this inequality says X has to be just greater than 5. So if X is like 5.1, 5.1 would make these two just long enough to make a triangle. They'd be just bigger than 18. But X also has to be less than 31. So X could be like 29. And then 29 together would allow me to still make a triangle. I could have X any value all the way up to 31, but not including 31. So I could use 30.9, but not 31. Theorem 5.7 and Theorem 5.8 tell me how the sides and angles of a triangle relate to each other. If I look at example number 4, AC is the shortest side in my triangle, followed by BC, followed by AB. Notice this triangle, just like examples 1 and 2, are not drawn to scale. Trust the way the triangle is labeled, not the way it looks. So if AC is my shortest side, Theorem 5.7 tells me where my shortest angle is going to be, my smallest angle. Across from 8 is B. So angle B will be my smallest angle. Followed by, across from 9 is angle A. And across from 10 is angle C. Notice how I use this symbol for angle, so it does not look like a less than symbol. In example number 5, I know two angles in a triangle. In order to figure out what the smallest angle is, I need to figure out the measure of this third angle. Well, all triangles have to be 180 degrees. So I can take 180 and subtract 80 and subtract 60 to figure out that third angle. And that third angle is 40. So D is actually my smallest angle, followed by angle F, followed by angle E. Theorem 5.8 tells me how the sides relate to the angles. Well, if angle D is my smallest angle, the side opposite that angle will be my smallest side, followed by the side across from angle F, followed by the side across from angle E. If we look at example 6, the triangle inequality theorem says that any two sides of a triangle added together have to be greater than the third side. So I'm going to say MN plus MO has to be greater than NO. These two sides added together have to be greater than my third side. So I'm going to plug in my values for these sides and solve for x. 3x plus 2 plus x plus 3 has to be greater than 5x plus 2. Combine my like terms. 3x plus x gives me 4x. 2 plus 3 gives me 5. Now I need to solve for x. I have 5x on the right and 4x on the left, so I'm going to subtract 4x to keep my x positive. Subtract 2 from both sides, and I end up with 3 greater than x. But I always want to have my x on the left side, so I'm going to flip this around and compare x to 3. 3 had to be greater than x. When I flip it around, x has to be less than 3.